Welcome to the demonstration of tspDB, a system that integrates predictive capabilities into time series databases. This work is done by Anish Agrawal, Abdul Al-Omar, and Devavrat Shah at MIT. Time series is an important form of data that we encounter in many domains, such as physical systems, retail, and finance. And when it comes to time series data, there are two common prediction tasks. The first is imputation, which aims to overcome two data quality issues: noisy observations and missing values. The second is forecasting, which aims to make predictions of future values. But how do we perform such predictive tasks? Well, let's look at a typical machine learning workflow. In a typical machine learning workflow, you first query the data from a database, start the data preprocessing and engineering phase, train a machine learning model, evaluate the trained model, then repeatedly tune the hyperparameters until finally deploying the model. This process is problematic because 1. Preparing the data in the appropriate format and tuning the model's hyperparameters is a tedious and time-consuming task. 2. The complexity of these steps makes it more prone to error. And 3. As new data comes in, updating the model would require repeating the whole process, making this workflow not very suitable for real-time applications. In tspDB, we aim to ease the burden of this process. We do so by integrating predictive capabilities on top of existing time series databases. Additionally, we present an SQL-like interface that is easy to use for analysts familiar with SQL. In tspDB, building a prediction model is as easy as building a standard index in relational databases. Similarly, producing a prediction through tspDB predict query is as easy as writing a standard select query. You can enable this predictive functionality on your own database in 3 easy steps. Let's demonstrate through an example. Let's look at a time series database with this table containing the daily stock prices of 3 companies from day 1 until today, which is day 300. Despite the missing values in the table, you want to forecast the price of stock 1 for the following day. The first step to achieve this is to install tspDB on top of your time series database. The second step is building a prediction index on your column of interest, in this case, stock 1. Similarly, you can build the prediction index on multiple columns simultaneously, which enhances the prediction accuracy. Building the prediction index enables the third step, writing a predict query. Specifically, you can write this one-line predict query to forecast the price of stock 1 for the next day. One important question is, how accurate are these predictions? Our empirical evaluation shows that tspDB outperforms Amazon's deep learning method, DeepAR, Facebook's Profit, and LSTM neural network. Further, tspDB provides confidence interval to quantify the uncertainty of its prediction. But what about tspDB's computational performance? Adding tspDB does not affect the insert throughput of the original DB. For example, Postgres can insert data in 6.1 microseconds per record, while tspDB updates its model in only 3.8 microseconds per record. Also, the predict queries has latency similar to that of select queries. A select point query takes about 0.5 milliseconds, while tspDB's predict query takes 0.9 milliseconds. To get your hands on tspDB, visit our project page at tspdb.mit.edu and experiment with our demo there. Meanwhile, let's do a quick walkthrough of that demo. In this live demo, we will demonstrate tspDB functionalities when it's built as an extension on top of Postgres. In this use case, we will see how to forecast electricity demand, a common and crucial application for time series data with huge economic implications. For our dataset, we will use a subset of the publicly available electricity dataset from the UCI repository. This dataset is one of the standard datasets in the multivariate time series literature. We already have this dataset loaded into our tspDB database, where we stored it in the table electricity. First, we will connect to our tspDB database through the Python library psycopg2 and inspect this dataset using the select query. This dataset has 11 columns, a time column, and a column for the hourly demand of each house, from house 1 to house 10. In the following steps, we will show how to use tspDB to forecast the next 3 days of the electricity demand of house 1. Let's illustrate this visually. In this figure, the blue line is the data we have stored in the database, while the black dotted line is the test data representing the electricity demand for the next 3 days that we want to forecast. In tspDB, you can forecast these 3 days in 2 simple steps. First, we need to build a prediction index on the column we want to predict. We can also build our index on multiple columns to enhance the prediction accuracy. In this demo, we will build the prediction index on the 10 columns H1 to H10. In tspDB's extension over Postgres, you can create a prediction index using this one-line command, where you need to specify the table name, the time column, and the columns you want to build the index on. Let's go ahead and build our prediction index. And just like that, the prediction index is built. Now, the user can use tspDB's predict queries to forecast future values as well as imputing values in the past. You can forecast the next 3 days by simply writing this predict query, where you need to specify the table name, the column, and the time range you're interested in. Let's now run our predict query. And now these predictions are reduced. Let's now visualize them along with the actual values. In this figure, the orange line is tspDB prediction, while the dotted black line, as before, denotes the actual values. And as we can see, tspDB predicts the next 3 days with high accuracy. And not only that, but the confidence interval, shown in green, almost completely captured the variation in the observations. So we just showed that in tspDB, through 2 easy steps, you can predict future values as easy as performing a simple select query in standard databases. And for even more interesting use cases of tspDB, such as its imputation capabilities, its estimation of the time-varying variance, and its computational performance, visit our live demo at this link.